Multipliers. It is one of the topic that is related to optimization in the case of multivariate calculus. So we are not going in the depth and the concept of this topic, but what we are doing, we are just discussing it superficially and trying to solve a problem and define what is the working rule to do that. So what is the main idea? Our main goal is to optimize a function. Let's say the function is xy plus 1 and subject to some given constraint. Let's say it is x square plus y square minus.
So constraint means what?
Constraint means limitations. So you are supposed to find out the maximum or minimum value of this function subject to this curve. It means the maximum or minimum value of this function that lies on this surface or on this particular curve. So that is the main idea behind this. It means, you know very well, if I put different values of x and y, I will get some more and more greater values or some very less values. But I have to find out the maximum which lies on this surface and the minimum which lies on this surface. So this is a particular constraint. For example, in the case of single variable, what you do, you are given a function and the function is defined in this way. You are supposed to find its maximum or minimum values and you claim that this is going to be the minimum value. But if I give you a constraint that your function starts from this interval, then your end points will also give you some sort of minimum or maximum values. If I say that you have a function which is defined in this way. Okay, what is going to be the maximum value and what is going to be the minimum value in this case?
Minus infinity.
But in the set of real numbers, minus infinity is not a number, it does not exist.
Does not exist.
Plus infinity does not exist.
Yes,
So simply we can say that the maximum or minimum value of this particular function does not exist.
Does not exist.
Because what happens when you graph this function, this goes like this. It goes to negative infinity and on this direction it goes to positive infinity.
Yes, sir.
What is the minimum value? We don't know.
We don't know.
It does not exist. What is the maximum value? Does not exist.
Does not exist.
You can call it minus infinity and plus infinity, but it's not a number.
Yes, sir.
But what you do when you give a constraint,
Yes.
subject to means you give a constraint. Let's say the function goes from only negative 2 to 2. It means this is your minimum, this is your maximum.
Yes, sir.
So you have to cut off your function here. Now this is going to be your minimum and this is going to be your
Maximum.
Otherwise it does not exist. So this is what you call a constraint is.
Constant limitations.
Limitation. So there is a theorem what we call extreme value theorem. It tells that when there is a function which is defined on closed and bounded interval
Yes, sir.
or closed and bounded region, because interval in the case of single variable, if you talk about multivariate, it's going to be a region.
A region.
It can be a circular region, it can be rectangular region or something like that. There are ways the maximum or minimum value of the function exists. If there is existence, otherwise if you are not restricting yourself to a particular domain, then you cannot claim that there would be any minimum or maximum value for that function. So we are going to write the theorem, but let us discuss what do we mean by Lagrange multipliers first. So what is the idea? The idea is that this is the equation of a circle, x square plus y square minus 1 equals 0. It is a circle in xy plane, but if you extend it to 3D, it becomes a cylinder. This is the equation of a cylinder, and this is another surface. So on that cylinder, you have to find out the minimum or maximum values of this particular curve on the boundary of that cylinder, not inside the cylinder, not outside the cylinder, on the boundary of the cylinder. But if you project down on the xy plane, the cylinder becomes a circle. And this is a function whose value you are supposed to optimize. It means either you have to give the maximum value or you have to give the minimum value. When you project it down the xy plane, you will get another type of curves. This is a fixed curve, but when you draw this family, this will be a family of curves. I gave you a page yesterday. If someone has, we can discuss what does it actually mean. So it will be a family of curves like this. And family means there would be another curve as well, like this. There would be another curve as well, like this, and so on. But we are interested in only single curve, which is tangent to this particular constraint. This is tangent to this circle, this is tangent to this circle, this is tangent to this circle here, and this is tangent to this circle here. And you know very well, this is the point of tangency, and if you do one thing, you find del f, it is going to be the normal to this surface. We discussed already. What is del f? It is a normal vector to the contours of a particular function. So this is del f. And what is f? F is this
function.
What is this? This is g. And if you make a normal to this surface, it will be del g. Because the graphs are basically tangent to each other, so the direction or simply the direction of their gradients will be similar. So direction of del f and the direction of del g would be similar to each other. It means you can say that del f will be equal to del g times some constant. Let's name this constant to be lambda. Okay. So when you want to optimize this subject to this constraint, what you do, you basically solve this equation along with g is equal to 0. So this is basically what we call the system of equations. You are supposed to solve these equations to find out the values on which this function is to be maximized or minimized. So this is what we call the working rule of Lagrange multipliers. So this is the thing that we are supposed to keep in our mind. We are done. And the idea is this. Because we know very well del f and del g are simply in the same direction because their tangent line is same. If you draw a tangent line, that would be tangent to both f as well as g. It means their normals will go in the same direction. They will not be equal. Their direction would be same. And if you know very well, if the two vectors have same direction, simply one vector is the scalar multiplication of another vector. So del f and del g are a scalar multiplication of each other. So this is that case. Their direction would be opposite, but we simply say that they have same, their angle is 0. Their angle is either 0 or when the direction is opposite, their angle is simply 180 degrees. But if the direction opposite, this lambda would simply be negative. If the direction is similar, then the value of lambda is going to be positive. So you have to solve this system of equations simultaneously. You will get the maximum or minimum values for the function that you have. So this is simply the idea behind Lagrange multipliers. So in tests, basically they never ask about so many complicated questions. They will ask you the idea. So the idea is this: when you find the maximum or minimum values of a particular function, you solve the system. And this is system of how many equations with how many variables? This is a good question. This is system of how many equations with how many variables. Let's do this in this case. What is del f? It's a vector. What is the first component of the vector? The first component is partial f by partial x. What is the second component? Partial f by partial y, and there is a comma in between.
Yes, sir.
So what is partial f by partial x? The derivative of x is 1. The derivative of 1 is 0.
0.
So you are left with y.
Y.
And then
X.
derivative with respect to y is going to be 1. So this is only x.
X.
Equals lambda. This is lambda. And del g is again the same thing. Partial g with respect to x and partial g with respect to y. And this is your g.
Yes, sir.
What is partial g with respect to x?
2x.
Derivative of this? 2x.
2x.
This is 0. This is 0.
Yes, sir.
So 2x and this will be
2y.
2y. What you do now? You simply multiply lambda inside 2 lambda x, 2 lambda y.
Y.
You have this as a vector, this as a vector. You equate their components. What is the first component? What is the first component?
2 lambda
Y is equal to 2 lambda x. What is the second component? What is the second component? 2 lambda y. So this is like a system of equations which comes from only this. What is the next equation? G is equal to 0. What is G?
X square plus y square.
X square plus y square
Minus 1.
minus 1 equals 0 or equals 1.
1. Yes, sir.
So when you solve this, you get a system of
Equations.
3 equations. So you solve this, you get a system of 3 equations with how many variables?
Lambda that come. 3.
Lambda is there.
3.
You have to find the value of lambda as well.
Yes, sir.
So 3 equations, 3 variables. If you have 3 equations and 2 variables, this might lead to something which is not okay. So now we are supposed to solve these. So let us do it here. Are you okay up to here? So you just keep that thing in your mind,
Yes, sir.
and after this, using these, we got these 3 equations.
Yes, sir.
Now let us solve this. How to do? How to solve?
Substitute value of y.
What's the value of y?
Y.
2 lambda x.
Yes, sir.
Put this in this
Yes,
one.
sir.
Then this becomes
4 lambda square.
x is equal to 2 lambda times 2 lambda
X.
It implies the value of x would be
4 lambda
4
square.
lambda square x. So x minus 4 lambda square x equals 0. And am I okay with this?
Sir, yes, I agree. Linear equation I agree quadratic solve. Then you solve on a sum.
No. Is this okay? It means here you get 2 conditions.
Yes, sir.
Is it okay?
Right, sir.
One is x is equal to 0, another is 4 lambda square equals like negative 1, but negative gets cancelled.
Positive
Lambda square is equal to 1 upon 4, so lambda is equal to plus minus
1 upon
1 upon 2. So first take this condition. Is x 0 okay or not? So you got this, and the separate pairs are equal to 0. The value of x is 0, and from here the value of lambda is plus minus 1 upon 2. If I put x is equal to 0 here, then what happens?
y is equal to 0.
Y becomes 0.
Yes, sir.
X 0, y 0. 0 square plus 0 square would be like 0. 0 equals 1. This is a contradiction.
Contradiction.
So, we will simply neglect this because that value does not satisfy g equals 0. So, go for the next condition. That is lambda is equal to plus minus 1 upon 2.
True.
So, how can you apply this thing to find out the value of x
Yes.
and y? Hanji.
Sir, put again y is equal to 2 lambda x in third.
Now squaring 1 and 2 and then
y is equal to 2 lambda x. If you put the value of lambda to be plus minus 1 upon 2 x, then this becomes y is equal to plus minus x. It means either the value of y is equal to the value of x, or the value of y is going to be the negative of the value of x. Okay, so you take this value and put in this one.
Yes, sir.
X square plus what is y? Y is plus minus x
Square.
equals 1. So this simply becomes x square. So this becomes 2x square equals 1. X square is 1 by 2. X is plus minus 1 upon under radical 2. Okay, so how many conditions do you get basically? You get these 4 points. If you take x is equal to 1 upon square root of 2, the value of y takes 2 conditions. One is a positive x, another is negative x. It means either y is 1 upon square root of 2 or y is minus 1 upon square root of 2. So these are 2 points. Which points are these? One is this, 1 upon square root of 2 and plus 1 upon square root of 2, and this is 1 upon square root of 2 and minus 1 upon square root of 2. And the next point is take the value of x to be minus this, then the value of y would be either minus or positive. Then you get this is minus 1 upon square root of 2 with plus 1 upon square root of 2, and this point is minus 1 upon square root of 2 with minus 1 upon square root of 2. So you got 4 points after solving this. Now you have to check that out of these 4 points, which one gives us minimum value and which one gives us maximum value. And how you do it? Just take these values of x and y, x and y, x and y, and x and y, put in this f. When you put both positive in this one, this will give you a positive number.
Positive number.
And when you will put both negative in this one, this will give you the same value. It means there is maximum at these 2 points. But when you will put one negative and another positive, or one positive another negative in this function, this will give you whatever value,
Yes,
but it would be smaller than the other value.
other value.
So these 2 values will give you the minimum, and these 2 values will give you the maximum. But these are your candidates for minimum or maximum, subject to this constraint, using what we call Lagrange multipliers. Okay, so this is the idea. What you need to keep in your mind, only this system, and sometimes the question is asked in this way, okay, how many equations and how many variables are there when you expand this system? It depends upon how many variables are there in f. It is not necessary that f only depends upon x and y. It might depend upon x, y, and z. So here how many variables are there? 2 variables, and third variable is lambda. So there would be equation in which there would be 3 variables, x, y, and lambda. If there is z, there would be 4 variables, x, y, z, and lambda. And how many equations?
4.
How many equations from this one depends upon the quantities in your vector. How many quantities are there? 2 quantities. If there would be 3 quantities, there would be 3 equations from this one.
Yes, sir.
One is this, so there would be 4 equations. In this case, 2 equations from this one and 1 equation from this one means 3 equations.
All variables are in the system x, y. Can't we write z?
We can. No, I mean to say that f only depends upon x and y, but f might depend upon x, y, and z. I think your question is, can we write this thing as z? Is that?
No, sir. In the domain. In this
Yes, we can write. That would be a function of 3 variables, but the idea would be same. But now we have only 2 variables, since there is no any z. So this is how we deal with the problems related to Lagrange multipliers. So in tests, they might not ask you very detailed questions, but there would be very fundamental questions. Okay, what is the idea? What you solve when you deal with Lagrange multipliers? How many equations are there? And then once you get all the required points, then you have to check that whether which value gives you minimum and which value gives you maximum. It's very easy. So the next idea is what we call the integration of higher order. It means double and triple integration. We know very well what is the idea behind that, but we are somehow getting the concept behind that what is happening basically. So, what you do in single integration? You want to integrate a function, let's say f of x,
Yes, sir.
between some intervals, let's say a and b,
Yes, sir.
and you are interested in area under curve.
Area under curve.
So, you take this domain and this one, and you are interested in this whole area, which is below this curve, but only between this range from a to b. This is what we call single integration. And what you do, you break down this into smaller rectangles with the length of each rectangle to be named as delta x. So you may take different lengths, but we are claiming here that the length for each rectangle or the width for each rectangle is same,
Yes, sir.
and the name of that one is delta x.
Delta x.
Okay, then what you do? You find this height. And what this height would be, this would be equal to f of x, but let's say it is evaluated at I, and this is equal to delta xi. So when you multiply these quantities, you will get the area of this
Rectangle.
rectangle.
Yes.
Then you add all those areas, you will simply get one approximation to area under curve. And if you want to get a better approximation, what you will do, you will make this rectangle, the width of this rectangle to be as small as possible. It means from A to B, you will be making more and more rectangles, and more rectangles means n tends to infinity. It means you are going to divide interval AB into n parts. Then you are going to increase the value of n as much as possible. And in mathematical words, we call it n goes to infinity. So what would be the area? Area would be approximated by the value of the function at xi, means this, multiplied by delta xi, and you take their sum from 1 to n, and take limit as n goes to infinity. And you can rewrite this whole thing using this symbol, what we call integral from a to b, and this integral simply stands for this
Yes.
sum and limit, and you write f of x dx. This is what we call area under curve. You take the value of the function and you multiply this with dx. We call it length element because this is dx stands for this length.
Delta x.
We call it length element. But what we do now, we extend this idea to a surface. We have this surface, and we have some domain. Let's say the domain is some sort of rectangular that goes from 0 to A and 0 to B in the y direction, and you want the area above this region on this surface. So this area would be, basically you want volume below this surface
Yes.
in this domain. So what do? you do the same thing. What you have taken from here, you have taken a length element. Now you will do one thing, you will divide your domain into smaller rectangles, and you will take one piece from here, and we name this piece to be area element. What we name this? Length element. What we name this? Area element. What would be the area of this region? We know very well this piece is called delta xi, and this one is called delta yi. So the length of the area of this rectangle is going to be delta xi times delta yi. Now you multiply this with the corresponding height of the function above this, whatever it becomes. And we are going to name this height to be f of xy yi. So multiply this with f of xy yi. Then simply you take sum when I runs from 1 to n, and when you take limit as n goes to infinity. But simply we cannot say this will be I. What is the reason? Because you are running in both directions. So you should better write j. I for x direction, j for y direction. Then your sum will run for both I and j starting from 1 to fxn. And you may run separately the sum for I and separately for j as well. And this is how you get the volume, but we may call this to be approximation. This is the approximated volume below the surface. And when you want to write this in terms of integration, this becomes a double integration because there is a double sum. One runs from I, one runs from j, and this integration in x direction is from 0 to a, and in y direction from 0 to b. So in x it is 0 to a, in y it is 0 to b. You may name these to be AB and CD, it doesn't matter. F of xy dx dy. So these dels becomes dx and dy when you apply limit to these. So this is how you find the volume below a given surface. So what is the idea behind this? This is the length element multiplied by the value of the function. As earlier defined, this value of the function gives you height above that point. And what is this? This is area element multiplied by the value of the function. And what does this give? This gives the height above that particular rectangle. And when you multiply, and integrate means take their sum, this becomes volume. And that is what we call the area element. And evaluating a double integration is not a big deal. You know very well that thing. But there is a problem here that we should discuss. Otherwise everyone knows how to evaluate a double integral. But we are doing some examples as well. Your function value is 1. F of x comma y is 1, and dx dy is same, and your limits are now from a, b and c, d. So one thing you should keep in your mind, the limits for x are from c to d, and for the limits for y are from a to b. And when your function is a constant, then simply you are not supposed to evaluate the integral. Your answer would be b minus a, upper minus lower, multiplied by d minus c, that is upper minus lower. That's your integral. When you will evaluate, you will get the same thing.
Yes.
But this is simply a trick that you can apply. When you integrate 1 with respect to x, that becomes x. What you do? Put the upper limit, that is d, minus lower limit, that is c. So you get d minus c. And when you do this integration, integral dy would be equal to y. You simply put upper value, that is b, minus lower value, that is a. You can extend this double integral in this way to triple and fourth order integral as well, but these are the extensions. We only need double and triple integrals. So this idea can be extended from single integral easily, but now I want you to evaluate this. It's very simple integral. For y, the limits are cube root of x. It's not 3 square root, but it's cube root. To 2. And this is our integrand. And for x, the limits are from 0 to 8. Any suggestion or any hint?
Partially or tan inverse.
You
Yes, sir.
just remove this thing and you remove this thing. This becomes a single integral.
Single integral, yes, sir.
How to do it?
Tan inverse y square plus 1,
Tan inverse.
y square plus 1. Again, for limits. My second option partial.
In NTA subject specialist, you found whatsoever question, but this question is much mandatory.
Mandatory, no?
Mandatory. You will find there. When I went there actually, I just went only once. So I asked my colleagues that what type of questions are there. So same thing is told by Sunny Kumar that this question will be there. So keep this thing in mind. And option is B. So might be someone who go there for subject stress. So this question must be there.
And option is B.
Option is B.
Option is B.
Option is B.
How is
This
it possible?
is constant actually, whatsoever the logic is.
But my logic is this. You are going to integrate a constant.
B.
Let's say for x, the limits are from t1 to t2, and these two are constants.
Alright.
And for y, the limits are from, let's say, t3 to t4. These are some constants.
Alright.
And for z, the limits are again t5 to
T6.
t6. Since this is a constant, keep it same.
Alright.
Check the limit of x, y, or z, whatever.
T2 minus T1.
t2 minus t1
Alright.
multiplied by
T4 minus
t4 minus t3
Hmm.
multiplied by
T6 minus
t6 minus t5.
Okay.
You can apply it to anything, dx, dy, dz, and 2 to 4, 4 to 8, 8 to 16, or whatever. So this is
Just
4
multiple.
minus 2,
2.
that is 2 multiplied by 8 minus 4 is 4.
4.
16
Eight.
minus 8 is 8.
2 for the
Yes,
8, 8 and
64.
64.
This
Yes.
can be applied here.
Yes, yes.
Here simply integrating this function which is 1 upon y power 4 plus 1 with respect to y from these limits using our ordinary rules which we deal in calculus is not possible. Is not possible. But if we go for some techniques in complex analysis like residue theorem or some others, then it is possible. But it is not possible in elementary functions. But there is a good thing that you can, if you have double or triple integral, you can change the order of integration and then you can do it possibly. The order of integration is dy dx, you may change it to dx dy, then it might be possible.
What about Fibonacci theorem?
About?
Fibonacci theorem.
Yes, Fibonacci theorem, same thing we will be applying, but that's the rigorous way. Here we have to only change the limits.
Alright.
That's all.
Alright.
But the main idea is how to change the limits. Now I am interested in one thing. I am integrating the same function, but not in this order, in this order. We call it iterative integral, and iterative integral is such an integral in which you can swap the limits, and you can swap their order,
Yes, sir.
but it is not possible always. It can be done with the help of Fibonacci theorem. That is a part of real analysis or measure theory. Now you have to change these limits only. This is the main thing to be discussed. These limits are for y, and these limits are for
X.
x. So let us discuss what does it tell. What is the region basically? What are the limits for x? The limits are x
0 to
from
8.
0 to 8. So let's say this is 0 and this is
8
8. So x runs from 0
to 8.
to 8. And y runs from cube root of x. So y is cube root of x, or we can say that y cube is equal to
X.
x. So it would be a function that looks like this,
Just like.
just like that. So the value of y starts from this and it ends where?
2.
The maximum value is
2.
2. So what is a region? A region of interest is this one. When you see in this region, what is the minimum value of x?
0.
0. What is the maximum value of x?
2.
8. X.
8.
X starts from 0
To 8.
to 8. So this is x. And y runs from,
0 to 2.
when you go in the direction of y, you always go vertically.
Yes, sir.
Y starts from cube root of x,
X.
because this is this cube root of x, it goes to 2. So what do you do? One limit is always, one of these limits which is outside is always telling us the minimum value and maximum value. And one of the limit which is inside is exactly telling us this region.
Region.
One limit is minimum and maximum, and the other region tells us only the restricted domain, whatever it is. So the inside value is for y,
Y.
which is the restricted domain,
Yes, sir.
and outside is for x, which is the minimum value and maximum value. Now what is outside?
Y.
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 So outside would be the minimum value and maximum value. In the case of y, what is minimum value?
0.
What is maximum value?
2.
So
This becomes
this limit becomes
0 to
0 to 2. Now this inside would be your domain, your restricted domain. It means that would be the value of
X.
x. So what you do in this case, in this region you pass a horizontal strip or a horizontal line. Why horizontal? Because we want limits for
X.
x. See that when does this enter your region? This enters your region from here. What is the value of x here?
0.
0.
Yes, sir.
And when it leaves your region, it leaves your region here.
And
What is the value of x here?
Y cube.
You are done. This is how you change the limits and change the order of integration. Once it is done, now integrate. And I think now it becomes easy.
Simpler.
And why it is easy?
So with respect to x, this becomes x, and y cube is simply there, and we can divide it.
Yes. Now you integrate this with respect to x.
Yes,
So
sir.
this is a constant.
Constant.
X will be there.
This is a constant.
Yes, sir.
So if you integrate with respect to x,
X upon
take
Y.
this thing outside. Integral dx would be x.
X.
Upper limit minus lower limit, only it becomes
Y cube.
y cube minus 0. No need to write. Now this is a single integral. This is the function y power 4 plus 1.
Derivative is
What is the derivative?
3y cube. So
4y cube.
4y cube, yes, sir.
4. 1 upon 4
log
log y power 4 plus 1.
1, yes, sir.
Lower limit and upper limit. So 1 upon 2. Sorry.
4
1 upon 4.
Log 17.
2 power 4, 16 plus 1 log 17.
Log 17.
Minus log 1, which is 0. So
so
this is
no
your
need to write.
So in single integration, it is not possible to do some sort of difficult or weird questions, but in double integration or triple integration, it becomes very easy. Once you change the order of integration, you are done. And in most of the tests, they never ask about, okay, find the exact value. Sometimes they ask, okay, when we change the order of integration, what does the limit become? Because when you change this order, what are the limits? That's the main question. The limits are from now 0 to 2 and 0 to y cube, and this order has been reversed, and there would be no any effect on your integrand.
So थोड़ा ये हो चुको ये लाइन की क्रॉस की थे ना कि थोड़ा एलोबरेट देखियो यो x
The first thing is that this limit is for x.
ठीक है
That gives you minimum and maximum value. This is your minimum and this is your
बस
maximum. Now this inside limit is for y. That gives you the exact region.
ठीक है
So you draw a vertical line, and this enters your region at this. And here, what is the value of y? The value of y is cube root of x. And when it leaves your region, the value of y is exactly 2. So exactly 2. So I just draw this region. Now I want the reverse order. Now this outside thing becomes y. It means for y I need the maximum and minimum value. The minimum and maximum. So you see, for y the minimum is 0. Now the minimum is 0. And the maximum is 2. So that's from 0 to 2. But for x, I draw a line or a strip or some sort of arrow, which when enters my region and when leaves my region are two most important points. You have to tell what is the value of x here.
0
That's 0. That's a lower limit. And you have to tell what is the value of x here.
ये ग्राफ
And how you can find out by using this. By using this, I got that the value of x becomes y cube. So that's right. That's all. This is how you change the order of integration. This thing is a bit easy in double integration, but it might be somehow difficult in triple integration. Not that much, but we have some polar coordinates or cylindrical coordinates and spherical coordinates that might help us in that case. Okay, if I want to change any integration into polar coordinates, then what are the changes required? Because it is not possible to solve every integral in Cartesian coordinates, and it is possible but difficult. But when you go to polar coordinate, it becomes something very easy. So let us discuss that thing. So when you find area under a curve, you have this integral f of x dx. Is it the case?
Yes.
A function defined from a to b. I call dx to be the length element. So I am going to generalize it to write dl. dl means the length of one strip, and f of x means height. So when I multiply that thing with this, that becomes the area of a rectangle. And when I add those all, that becomes an integral. What do we have in double integral? We have this region. Let's say it's a rectangular region. And we have a function. And we have an area element.
Area element. Yes, sir.
And in xy plane, that's the area of a rectangular square type shape. And f of xy is the height above this. And that gives us a surface. So we are getting this volume below that surface.
Yes,
This
and we
become,
call this thing to be area element.
so this become cube actually.
Yes, this becomes cubite.
Cubite.
Cubite, or it's in generalized words it is called rectangular prism. Rectangular prism.
So again we are supposed to add them and taking
Yes.
limit and this become Riemann. Alright.
Yes. Now what happens that this area element is different for different systems of coordinates. We know very well in Cartesian this area element becomes dx dy, because simply this is dx and this is dy, so the area of this small region becomes
dx and
dx dy. And when you go to polar coordinates, this becomes
r cos
r
theta.
dr d theta. Now there always arises a question, why there is r there?
Because x is equal to r cos theta and y equal to r sin theta.
Yes, that is one reason. And one reason is simply this is because of
Jacobian.
Jacobian.
Yes.
This is because of Jacobian. Because when you change the variable, you always introduce something is called compensation. And compensation is what we call Jacobian. There are another reasons behind this, that why there is r in this. But for test point of view, you should know that for area element in Cartesian we have dx dy. In polar coordinates we have r dr d theta. And if you don't introduce r dr d theta, you only introduce dr d theta, simply you will get something wrong as your answer. Now we can apply the same thing to solve some sort of integrals which are somehow complicated, and we call them, let's say, the Gaussian integral.
Belcher.
And this integral is from minus infinity to infinity, e power minus x square dx, and the answer is square root of pi. Square root of pi. When the limit is whole, minus infinity to infinity, that is this, and when the limit is from 0 to infinity, this is only square root of pi divided by 2. So this thing is asked so many times. When you draw the graph, it looks somehow like this, a bell type shape, and when you find the area under this curve, the answer is the square root of pi, from minus infinity to
Plus
infinity. But when you restrict yourself from 0 to infinity, this becomes half, so the answer would be square root of pi divided by 2. But the question is how to evaluate this. Simply you can do by changing the Cartesian coordinates to polar coordinates. And what are the equations for Cartesian to polar and polar to Cartesian?
x equal
We know very well x is equal to
r cos theta,
r cos theta and y is equal to
r sin theta.
r sin theta. This is polar to Cartesian. Because when I give you the value of r, I give you the value of theta, you give me the value of x and y, so this is polar to
What?
Cartesian. What is Cartesian to polar?
R equal to
R is equal to,
x square plus y square
and theta equals
tan inverse
tan inverse
y upon x.
y upon x. There is some restriction on this one as well, that whether you are in first quadrant, second quadrant, third or fourth. There is some restriction. But generalized definition is that. Now why these coordinates? What do they tell? It's something that we are not supposed to discuss. Because x and y tells that how many units you are going to move in x direction and how many units you are going to move in y direction. I am here, I want to reach at this point. I can define my movement in the horizontal and vertical direction only. Like I go this way and then this way. So this is my x direction, this is y direction. Another thing is that you just simply go straight. This is called r, and you tell me what is the theta angle
J.
with the x-axis.
This is the polar coordinate.
Yes, this is what we call the polar coordinates. So using these things, we can change our integral into polar coordinates. But this is done when we do something else. This is possible to be solved when we don't take I, we take I square. I square means these type of two integrals multiplied together. And for the next integral I am writing e power minus y square dy, and I can change the variable because this is what we call a dummy variable. We can change it. So I square, now this becomes minus infinity to infinity, minus infinity to infinity, and e power minus x square plus y square dx dy. Now I change this whole thing into polar coordinates. That would be easy. How do I do that? I know very well the value of x square plus y square becomes, when I square this thing on both sides,
R square.
x square plus y square becomes r square. So e power minus r square, is it okay?
Yeah.
And this is the area element in
dx.
Cartesian. In polar it becomes r dr
D theta.
d theta. Now what is my limit of integration?
When we put instead of y minus infinite, so r also become
Yes.
r also become infinite.
Maybe. What is the value of r and what's the value of theta?
R infinity is
Maybe, may not be. It's very simple, I think. R is from minus infinity to infinity, but why? Because we are taking the whole domain. That's the question. What's the graph for that? R from 0 to infinity is possible. So when we convert this from 0 to infinity, it becomes easy. Can we put the value directly and get our answer for x and y? For x and y, if you are going to put the value directly, is it possible? Okay. Let us make it from 0 to infinity, but for now just do it. And theta would be from 0 to 2 pi. So e power minus r square, the derivative of would be minus 2r. So just you give
minus 2 and
minus 2 and minus 1 upon 2. Just all these things, your answer would be pi after simplification. Now I square is equal to pi. Just take the square root. I would be square root of pi. We can discuss this thing, that why it happens, that's okay. Okay, now this is most common integral when it comes to some of the questions in tests by I think IVA, NTS as well as SPSC. And when you take this from 0 to infinity, this becomes square root of pi divided by 2. But there's a question, not the question, but I think we can apply this particular integral when we study gamma and beta function. We can apply this integral over there. And this is the famous integral, what we call the Gaussian integral, because it is related to, I think, a random variable called Gaussian random variable, and its mean or variance, it is related to that. Okay, so spherical, also called spherical polar coordinates, or simply spherical coordinates. So these are the ideas which would be a bit related to triple integrals and what we do there basically. So in Cartesian coordinates, simply we have three things, x, y and z. X tells us the movement in one direction, like what we simply call the length,
Yes, sir.
and y gives you another direction, means width,
Width.
and z gives us the height.
Height.
And if you have a point in this coordinate system and you want to reach at this point, you can always define this movement in three different components. What do? You simply start from here and you go in x direction, then you go in y direction, then you go in z direction to reach at this particular point P. Okay, you can only reach by using these three types of motions. One is in x direction, then in y direction, then in z direction. This is what we call x, y and z. And for example, if you want the volume of any region, using triple integrals, the idea would be triple integral around some region R and dv. What is dv? dv is your volume element. dv is your volume element. What do? You are given a crazy type of region. You take a piece from this region, and this piece is a cube. Its area is denoted, its volume is denoted by dv. You take those all the cubes in that box, and you add them, you get the volume inside that region. So this is triple integral over some region R, and the integral coefficients would be dv. And what is dv in Cartesian coordinates? This dv would be simply dx, dy and dz. This is that. But the case would be different in cylindrical coordinates, and it would be different in spherical coordinates or spherical polar coordinates. So how to do this? What are three components in cylindrical coordinates?
Theta, phi.
R, theta,
Z.
z. R, theta and z. What do? You have a point. First thing is that you project down this point on this xy plane. The projection on xy plane. And this height is called z. This is your z. Because this is your xy plane, this height would be equal to this height. Because this shape is a bit tilted, you know very well. This height is called z. You are projecting point downwards on xy plane. What is the second thing? Now your point is on xy plane. What you can do? You can find the distance from origin, we name it r. This is that r, and the value of r can be found by x square plus y square. And again, the angle theta would be with x-axis, which you can find by tan inverse y by x, and z would be equal to z. In both Cartesian as well as cylindrical coordinates. So I think polar coordinates is the case in 2D, and when you extend it to 3D, it simply becomes Cartesian coordinates. This is r theta same, you add just a third component, that is z. And one thing that I should mention here, the value of theta always runs from 0 to 2 pi. We can, but that equality will be again 0. That's why it is better to write this here. What about spherical?
R, theta and phi.
R, theta and phi. Now what is the case basically? And here the volume would be again integral over region dv. And what would be dv? R, dr, d theta, dz. This is the volume element in the case of cylindrical coordinates.
सर हिकिड़ी ज़ाहिर ॻाल्हि शेप थियल हूंदो आहे
Yes.
हिन एंगल जी हरकत बि हिकु ई थींदी स्पेरिकल में माना टे चवां ॿ एंगल जो हिकिड़ी डाउनवर्ड साइड ॿी लेफ्ट राइट में अची थींदी
Yes. Yes. So you are doing that thing over here. So is it okay? Just you need to keep one thing, that what is the volume element in this one and how we can change this. If I am giving you r, theta and z,
We can.
will you be able to give me x, y and z? It's very easy. If I give you x, y, z,
We can give you r theta z.
we can find out r, theta and z easily.
Vice versa.
So why these are called cylindrical coordinates? Because we specify ourselves on a particular
Cylinder.
cylinder. We take this point, project it down, and this is the cylindrical shape.
Height will be fixed here.
Yes.
No change.
Now what is in spherical coordinates? Spherical comes from what?
Sphere.
Sphere. So all the points lie on a specified sphere. So what I do, I have this point. The first thing is that I find the distance of this point from origin. I name it rho. Okay. So rho is going to be my first coordinate. And what would be the value of rho? Yes. The value of rho would be square root of x square plus y square plus z square using Pythagoras theorem. Okay, the second thing that defines my point is the angle with the positive z-axis. And what is that angle? Phi. I write it here. So, what is phi? Is the angle of this what we call position vector with positive z-axis. Can you tell me what should be the limit for phi? It means what should be the minimum value for phi? And
0 to pi.
0 to
Pi.
pi. Yes. It will never be 0 to 2 pi. It would be 0 to pi. Because if I have a point here and this is the point, then this angle would be less than pi. If I am taking point here, then
Again, it is
less than pi. So it will be from, so let me write here, phi would be from 0. Pi is possible, I think.
Yeah.
Pi is possible.
2 pi and 0 is same actually.
Yes,
Straight
correct.
angle.
So I got the value for rho. Rho is this. Then another thing is phi. I should mention some equation for phi as well, but I am doing this thing later on. And what is the third thing? Third thing is that again I do the same thing. I project this point downwards and I find the angle with theta, and I know, you know very well, theta is tan inverse y by x. But how can I find out phi? And simply how can I find out the relations between these all the things?
Well, suppose z down y is whichever suppose tangent inverse na.
Yes, yes, yes,
Z अगर y x से दर पे आना
yes.
तो उन्हें दर meaning inverse form क्यों?
Are you okay with this so that I can remove this one and we should do something here?
Yes.
Can we write in this integration form? Spherical.
Yes, yes, I am doing it here. So for this the volume element is dx, dy, dz. For this one it is r, dr, d theta, and this r is simply the Jacobian. I would have written all these formulas directly, but again, these all the things are written in books. Then what is the purpose to come here? So this is the point, this is rho, and this is phi. This angle is right angle. And the length of this side is rho. It is called hypotenuse, we know very well. This angle is phi. Do you agree with this that this angle will also be phi?
Alternate.
Alternate angles.
Z उल्टा.
Okay. And
Transversal.
this is base and this is height or perpendicular. I think we have a relationship for that. I think you would be agree with me. This would be equal to rho cos phi and this would be equal to rho sin phi.
So yeah, उन्हें जो radius R हुआ, इतने rho R होगा.
Is it okay or not? Simply we have a vector and this is its horizontal component and this is its vertical component. Or I have to change.
Vertical component must be our sign.
Perpendicular in front of it is the perpendicular. Perpendicular will be y in sine form.
Is it okay?
Okay, right.
Okay, whatever, but this is the idea. This would be phi, this would be phi, and sine phi would be equal to perpendicular.
Hypotenuse.
So sine phi would be equal to perpendicular upon hypotenuse, which is rho. So this perpendicular would be rho sine phi. This is okay, and this would be rho cos phi. So now this height, as we discussed already, is z. So what is z? Rho cos phi.
Rho cos phi.
So let me write it here. Z is equal to rho cos phi. And this is this side. And now I am going to make this another right triangle. You know very well, from this to this is the value of x. And this is the value of x. And this is the value of y. And this is our r. I think you are agree with this, that this thing is equal to r. X is equal to r cos theta, and this is our theta. And y is equal to r sin theta. So x is equal to r cos theta, y is equal to r sin theta. Do you agree with this? Now what is our r? Our r is rho sin phi. So rho sin phi. What is r? Rho sin phi. So this is how you go from spherical to Cartesian. Z is equal to rho cos phi. X is equal to r cos theta, but your r is rho sin phi. Y is equal to r sin theta, but your r is rho sin phi. This is how you go from spherical to
Cartesian.
Cartesian. And this is how you go from Cartesian to spherical, but one thing is missing, that is phi, because this is rho, this is theta. How about phi? That we should get from here.
Engineers x upon z upon phi.
This comes from this. Cos phi is equal to z upon rho, but rho is not good here. It should be Cartesian, so I am writing
X square
x square plus y square plus z square. Then cos would be cos inverse. Then this would be cos inverse z upon square root of x square plus y square plus z square. So this is rho, this is theta, this is phi. Phi is from 0 to pi and theta is from 0 to 2 pi. This is how you interconvert these things. Again, you have to basically see what is the position of a point to find out the value of theta, because theta is a bit misleading. And one final thing I think, what is the volume element?
dV.
dV in case of spherical. So volume would be the region dV, but what is dV in this case? That is simply d rho, d phi, d theta, but you have something as Jacobian, that is rho square sin phi. Rho square sin phi, d rho, d phi, and d theta. And you can easily use this particular thing to find out the formula for the volume of a sphere. You know very well, sphere. What is the formula for that? volume of a sphere. Formula
4/3.
4/3 pi r cube.
G.
Pi r cube. 4/3 pi, and let's take radius to be r cube. And how can you find your volume element is rho square sine phi and d rho d phi d theta. Then you have to just specify the limits that will give you the volume. And what should be the limits? What is the interior-most rho? Rho is the radius, 0 to r, the fixed r. And what is phi? Always from 0 to pi, because you are considering whole sphere. So that would be from 0 to pi. And theta would be
0 to 2 pi.
0 to 2 pi. You just evaluate this. This would be the formula for the volume of a sphere. And these all the things started to be difficult. Then finally, once you get the formula, now you just apply the formula to get your result. But the starting point for these all the things would be very much difficult, like this. How to find out the exact formula? That would not be the exact integration like this, but it would be the analogous case of this. Okay, any question? Now, in this lecture, we somehow discussed multivariate calculus, and we are unable to start even the thing that we are supposed to discuss today, what we call real analysis, or there is another second portion of multivariate calculus, we might call it vector calculus, that is still remaining. But as discussed already, we will be doing that thing at the end, because in this one we have to discuss what is gradient, divergence, and curl of a vector field, what is the vector field itself, what is scalar field, and how can you find out the line integrals, the volume integrals, the surface integrals of these, and the main theorems like Gauss divergence theorem, Stokes theorem, and Green's theorem. These are the main things in the next course that we'll be doing at the end, after doing some other courses in applied mathematics. Like in the next week we'll be starting with differential equations, and